Hi, kids. Krusty. Okay, so we've got our angles, got our whole thing drawn out. And we've got height above the ground. And okay, so what do we do here? So basically you can, I've got all these rectangles, right? Rectangles are nice because if you have a rectangle, that means parallel lines. And if you have a line that dissects it, or what am I thinking? What's that? Corner to corner. It's basically a line that goes through parallel lines, right? Opposite angles. So if this is 17, then this is 17. And if that's 17, then this is 90 minus 17, 73, which means this big angle is 163. So you've got all this, but 90 degrees and 90 degrees. So got a 90-degree angle. This is 17, so that must be 17 opposite. So I've got this diagonal line through them. So 17. And if that's 17, then that must be 73. 73 plus 17 is 90. That's 73, 17. Okay, so now if I can, once I'm trying to find this length here. And so once I find this length, I can figure out the height above the ground and then G and all that, right? 17. So I've got an angle of, and then this big triangle, this is 2. So 17 minus 15. So this little one's 2. And so this little one over here so it's 180 degrees. So this is 17 degrees, right? So again, you can take this big triangle here and you've got a diagonal. And if this is 15, then that must be 15, right? Or you can go 180 minus 163 is 17 minus 2 leaves you with 15, right? So now we've got all these different angles and 75, 90, all that, right? Okay, so now I've got one side and all my angles in the triangle, so I can do a law of sines. Sine of, and I want to find this leg, so we'll call that D. Sine of 15 over D equals sine of 2 over 8,000. So opposite legs, opposite angles, and so D equals, it's going to be multiplied, or you can cross multiply and divide by sine if you want, or multiply by inverses. So sine of 15 times 8,000 over sine of 2. Divided by sine of 2. 59, 329. Right, there you go. Okay, now we want, what is it? Find the ground distance and altitude. Yeah, so we want the H and G, and then we can just use sine of 17 equals H over 59, 329, and then cosine of 17 equals G over 59, 329, right? Okay, so we got that. Right, so again, to do this problem, draw out your diagram of the thing, and you actually have a diagram that visually represents the problem. Label what you know, then label what you can find out given what you know, 90-degree angles, all that, okay? Okay, and then I think I just leave it in feet for this one, right? If you want to do miles, you divide by 5,280. Okay, pole tilting towards the sun. So it's just a slight tilt, right? Now this one depending on where the sun is, right? Say the sun's over here, it's just casting a shadow from the base of the tree to the end of the shadow, right? Now, I guess technically if this pole tilts far enough and the angle of the sun is low enough, then the shadow could be starting back here somewhere, but just ignore that possibility, right? I think given the various angles and the likely angle of the sun, what is it, 40? In the wintertime it's pretty low, but summertime it's pretty high, right? Angle of the sun to us. Okay, so anyways, it's 8 degrees off center, so that means this is 90 plus 8. And this one is 43. So I'm trying to figure out the height of the pole, 22-foot shadow, and therefore the opposite angle is it a 79 minus 39, right? So you got all that. How tall is the pole? Okay, so now we got a lot of signs. Sine of 43 over h is sine 39 over 22. Okay. And what is it? I forget, 17 or something? Sine 43 times 22 divided by sine 39. Yeah, 23.8. There you go, feet tall. So that's how tall the pole is, above the ground. All right, so now we got work. £45 force at a 30-degree angle. So 45 is the magnitude of the vector, right? And then it's at a 30-degree angle, and I'm dragging something this way 20 feet. So I need to find out the force, F sub x, we'll call it, of that vector. You find out the force of that vector times 20. So that's just a cosine problem. Right. Cosine of 30 is equal to the force over 45. So this equals root 3 over 2, 45. So that's 38.97, and that's just this, the magnitude. So I'm pulling with a tension on this line of 45, and some of that is going vertically, some is going horizontally. So we could actually write that as we'll just round off to 39, comma, and then you figure out the sine, right? So the sine would be half of that. Yeah, 20. Right, that's the vector, this vector with direction. So I'd say 45, and then cosine sine 30, comma sine 30. That's this vector itself, right? So that vector means we've got a little bit vertical, a little bit horizontal, and take my horizontal force times 20 is 779.4, right? Okay. And then you kind of do this similar idea here with the cart. Got a ramp, 25, got a cart. Now the cart has 100 pounds of force. That's the weight of the cart. That's how much gravity pulls on it. And then you've got that, given the angle here, some of that goes into the hill, and some of it goes down the ramp, right? So you got some force going this direction, and you need to hold it there, and you need an opposite and equal reaction force going the other direction, right? So we need to know what that force is, given this is 100. So this is 25. So we say sine of 25 is that force over 100. And of course, sine of 25 So 42.3 if you want. Right, so that's the force going up the hill. Okay, now let's do, should I do number 5? So remember yesterday we did the 6-3, we did dot product. 6-4, we did dot product. The easiest thing, of course, is if I have a vector 4-4 and a vector 2-3, I just find each individual angle and subtract them. So I'm going to go the arctangent of 3/2 minus the arctangent of 44/4, which is 45. So whatever this is, minus 45. And that's going to be 11.3. So, yeah. And then to find the magnitude of each one, use a distance formula. So this is 4-4 vector. This is a 2, 3 vector. And to find the magnitude, I'm going to go the square root of 4 squared plus 4 squared. And then this would be the square root of 2 squared plus 3 squared. Right? So this could be 2, and this is going to be the square root of 13. Those are the magnitudes. Okay, so let's skipping along to the final one. And that's the airplane with the speed of 750 and a bearing of 70 degrees. So this is the one that got you, I think, right? Got a few people, I'm sure. And bearing is, so here's due north, that's 0 degrees. And bearing is just off of due north. So if you have a bearing of 70 degrees, so that means 70, therefore that's 20. Wind hits with a velocity of 50 in the northwest direction, so bearing of 315, so that means right there. So that means that this angle, northwest direction of 315, right? So if I subtract 90, figure out what is this angle here, 180 plus 45, which should be 135. So I want to find, in order to use my sine and cosine, I need to get these in terms of the unit circle where I have my x-axis of 0, all right? So I'm going to re-coordinate here, if you will, reorient my directions. So now this is 20 degrees with a magnitude of 750, and then I'm going to have this, again, this wind is hitting it like that with a magnitude of 50. That's the velocity of the wind. And it's at 135, right? So you can think of 360 minus 315, so that means this is a 45-degree angle. And so this would be 90 plus 45, so now it's a 135-degree angle. So this is 50, the wind is 50 cosine 135, sine 135, and the airplane is 70 cosine 20, sine of 20. So you can add the resulting vector of where the plane ends up going should be, so notice that it looks like it's a little bit in the opposite direction. So my result, just guessing, my result 20 should be between 20 and 30 in terms of cosine beta, right? So theta should be 20, somewhere in this. And my speed, my force vector, should be somewhere in the interval, I'm guessing, maybe 700 to 740, right? Just totally estimating, and I'm using that to try to see if I can get once I get it done, to make sure my answer makes sense. So let's go ahead and add these together. All right, so I'm gonna go 50 cosine 135, plus 70 cosine 20. And 30.4. So that's the actual vector itself, right? And then I'm gonna go 50 sine 135 plus 70 sine 20. $59.3. So there's my vector, right? So my vector is, looks like my vector is something like that. Let me double check on that. 50 cosine 135 plus 70 cosine. Yep, 30 and then so 59, yeah, 59. Okay, so what's my angle? So I forget, what was the angle that I had in there? What did you put? Do you remember?
I don't remember.
Okay, I'll have to check, because so this is going to be like 60, right? So I mean, this is going to be, because my y is greater than, so it looks like something like that. Uh-oh, hold on. Ah, that's why. Nobody said anything. Dumb. Okay, try that again. Not 70, 750. What am I? Oh, that's why I had that. So, try it again. It should be 750, not 70.
Yeah.
Right, so I had 70. I think I was looking at that or something. I was like, that, I know that doesn't make sense, because the wind is not going to be that powerful. So, okay, try this all again. So 50 cosine 135. So I was very confused, by the way, maybe you could tell. 750 cosine 20. So that's going to be 669.4. Now I'll change those to sine. Okay. 291.9. That makes more sense, because it should definitely be more in this direction. More, it should be close to this, not like vertical almost. Okay, so I mean, it's going to be something like that. Right? So what's the theta? And I want to find the force, the magnitude. So the magnitude is the speed of the airplane. The angle tells me the direction it's going to fly. So theta is arc tangent of 291, which is, I just had, divided by 669.4. And I get 22.6, yeah. 22.6, and then my magnitude is the square root of squared equals squared, so. Squared. And that's going to be 730.3. Okay, so I said 700 to 740, so yeah, I mean, it's pretty close, right? So my magnitude, so my new vector, my airplane vector, the direction and magnitude that it's going, this is the vector, but if I want to write it this way, then I write the force of 730.3 times the vector cosine 22.6, comma sine 22.6. Okay, so now I actually will, I wanted the bearing though, right? So it's asking for ground speed and direction. So there's our ground speed. So ground speed of 730, you just round off, right? And then my direction in terms of the unit circle is 22.6. So, but in terms of bearing, it's just going to be 90 minus that, right? So bearing is direction from due north. So it'd be this angle here. And that's going to be 90 minus 22.6. That should be 67.7, right? Yeah. Okay, 6. 20 feet, 6. Yeah. 4. Yeah. So that would be the bearing. The bearing is off due north, and that's how airplanes' directions are. By the way, I don't know if I probably mentioned this before. Due north and magnetic north are, I think, like 11 degrees apart. So, and then magnetic north is believed to switch every so often. So once it does, then I think that'll screw everything up. A lot of GPS satellites and everything are programmed through due north, magnetic north probably. Your compass on your iPhone is probably something along those lines. I don't know. But okay, so that's the quiz. The exam, I had some similar questions, like the airplane, the first airplane, the last airplane. So similar problems. I'll probably throw a law of cosines on there. All right, I will stop this.